Hello everyone. Let us now discuss how can we solve this problem. Count the hidden sequences. So we are given with n integers differences, right? This is an array which describes the differences between each pair of consecutive integers of a hidden sequence of length n plus 1. More formally, call the hidden sequence hidden, then we have differences of I is equal to hidden of I plus 1 minus hidden of I. Now, I'll explain you clearly what does this hidden I and hidden I plus 1 will mean. Now, we are further given two integers lower and upper that describes the inclusive range of values lower comma upper that the hidden sequence can contain. Now, the differences are 1 minus 3, 4. Lower is 1, upper is 6. Now, hidden sequence is a sequence of length 4 whose elements are in between 1 and 6 inclusive. So here they took 3, 4, 1, 5. Let us see what does this mean, right? So 3, 4, 1, 5 and 4, 5, 2, 6 are possible, and let us just go to the example. Differences is equal to 1 minus 3, 4 and lower is equal to 1, upper is equal to 6, right? Now what I am doing for a brute force solution, this is the first approach, and I'll optimize this brute force to a better solution. But wait a second. Now lower is 1. What I am taking is lower is 1. Okay. Now I am adding my differences of 0 to the element. Let us say this element as EL, right? EL. Okay, I am naming this element as EL and I am adding 1 to EL. Then it will take 2, right? So what does this mean? Is 2 minus 1 will give us a difference of 1. This is what the whole question means. Okay. Now the element is 2 right now, so I just remove this EL. Now the element is 2 and I will do the same thing again. 2 minus 3, what will it become? Minus 1. But wait a second, right? I got minus 1. Does I have a minus 1 in this range? No, right? Minus 1 is lesser than lower, right? Oh, wait a second. Minus 1 is lesser than lower, right? What does it mean? Element is lesser than lower. Then what I need to do? I need to just skip it. I need to just skip it, and this is not a valid sequence or something like in right, hidden sequence. This is not a valid hidden sequence, right? Now I go to 2. Now I add 1 to 2, then I'll get 3. 3 minus 3, I'll get 0. But wait a second. 0 is not in the range of lower and upper. So just skip this, right? I'll just break the loop. Okay. Now I am considering 3, and 3 plus 1 is 4. 4 minus 3 is 1. 1 plus 4 is 5. Everything in the range of 1 and 6 inclusively. This is a valid sequence. Okay. In the code, I'll stop here, but for now, for your convenience, I am not stopping. When I get a sequence, I'll stop in the code, but here I am not stopping here. Why? I'll tell you why. Now I am going to next lower 4. 4 plus 1 is 5. Why I am taking plus 1? See here. Wait a second. 4 plus 1 is 5. Okay. 5 minus 3 here. 5 minus 3 is 2. Okay. 2 plus 4 is 6. Okay. These are the only two valid hidden sequence. Now let me go to 5 also. 5 plus 1 is 6. 6 minus 3 is 3. 3 plus 4 is 7. Is it valid? No. It is not a valid hidden sequence. Why? 7 is going out of the upper. 7 is greater than lower, right? So if element is greater than upper, then also I am breaking my loop. Now, as I said, I will stop here. I'll tell you why I stop there itself in a few seconds. Now, let me go to the next sequence where we got lower is 4 and upper is 5. Now, as it is, I'll start with minus 4. Minus 4 plus 3. 3 minus 4 is minus 1. Right. Minus 1 plus minus 4, which is minus 5. Right. Here, minus 5 is if you see, is lesser than -4, the lower, right? So I'll stop there. Now I'll go to -4 and then -3. -3 plus 3 will give me 0, 0 minus 4, 4. 4 minus 4 plus 5. 5 minus 4 will give me 1. Okay. 5 minus 4 will give me 1. 1 plus 1 will give me 2. 2 minus 2 will give me 0. Okay, this is a valid sequence. Now, what I mean every time when I say here I'll stop, let me see, is it, yes, -3, 0, -4, 1, 2, 0. Okay, this is a valid hidden sequence. Now, as I said, I will stop here in the code. I'll tell you why I am stopping at this moment when I get a valid sequence. Now, what I'll do is I'll just take upper, right? I'll just take upper. Now, what are the elements that I can get from this -3 to upper? Let me check. I will get -3, -3, -2, -1, 0, 1, 2, 3, 4, and then 5. Simply, if I tell you 5 minus -3 plus 1. Okay, okay for now, right? So this I call it as temp of I. Okay for now, temp of I got a temporary array which is a hidden sequence, a valid hidden sequence. And what is 5? 5 is the upper, right? So 5 plus 3, 8 plus 9, right? 5, yes, I got 9, 9 valid numbers, right? I am just assuming 9 valid numbers. Upper minus temp of I plus 1, which gave me 9. Okay. Now, I'm just removing it from here. Here I got 9. Now, what will I get for 0? 5 minus 0 plus 1. 5 minus 0 plus 1 will give you 6. Do I have a 6 number of sequences? No. Let me check again. -4, right? 5 minus -4 plus 1. 5 minus 4, 5 plus 4 is 9 plus 1 is 10. So why I am doing this? Why? Because when I get from 1 till something like 2, these are only the numbers that I can get. Now I got 5. At this moment I will do upper minus temp of I. I'll do it. Upper minus temp of I is 5 plus 1 will give me 6 minus 5 is 1, 1 plus 1 is 2, which is our answer. So every time I will take the minimum of upper minus temp of I plus 1 every time. Now I will store a mini for sure. So mini, so the mini will be updated to minimum of mini comma upper minus upper minus temp of I plus 1. Okay, for now this is our approach, right? I'll let me go to the every element. Now 5 minus 1 is 4 plus 1 is 5 again. 5 minus 2 is 3, 3 plus 5 minus 2 is 3, 3 plus 1 is 4. 5 minus 0 is 5 plus 1 is 6. So I'm assuming that there are 4 sequences. Let me check. Yes, there are 4 sequences. Till now I got here, it is the minimum from everything. I got 9 first, and then I got 6, and then I got 10. I got 5, 4, and 6 for all this temp array. So I'll return the minimum, but this is not the better approach, right? I'm just going and searching for here. Uh, like it will take a much time. So if I want to optimize this further, right? If I take 3, 3 minus 3 minus 2 will give me 3 minus 2 will give me 1, which is lower. Now 4 plus 2 will give me 6, right? So I need these values, right? 3 and 4. Let me name 3 and 4 as x, right? For now I am just assuming that this is the values of x. Now I need these two values of L and H. I am naming it as L and this as H. So what I'll do is x plus L should be lesser than or equal to lower, right? Now x plus H should be lesser than or sorry greater than or equal to lower, right? It should be greater than or is equal to lower, and it should be lesser than or is equal to, wait a second, lesser than or is equal to upper. Okay, x plus L should be greater than or is equal to lower, x plus H should be lesser than or is equal to upper. Why? Because we need all the values of x plus L and x plus H which comes in these values. If you can check, you can check, right? X and other value of x plus L, I am taking minus 2, and here I am taking plus 2. So if I take 3 as the value, 3 minus 2 will give me 1. Now 3 plus 2 will give me the value of 5. What does this mean? The highest value in your hidden sequence is 5. The lowest value in your hidden sequence is 1. Now, so if I take the value of x is 4, 4 minus 2 and 4 plus 2, right? 4 plus 2, right? So x plus L should be greater than or equal to lower. X plus H should be lesser than or equal to upper. Now I am taking the x value as lesser than or equal to lower, sorry, is greater than or equal to lower minus L. Lower minus L. Now x value should be lesser than or equal to upper minus H. Upper minus H. Now, if I write the same thing again, lower minus L is lesser than or is equal to x is lesser than or is equal to upper minus H, right? So, upper value is 6 and the higher value is 2 and the lower value is 1 minus L value is minus 2. If you remember, is minus 2, right? So here it is nothing but x plus L and x plus H which we are doing there. Now 1 plus 2 will be, I'll tell you what it will be, and x should be lesser than or equal to 6 minus 2. So x values should be in the between us of 6 minus 2 which is 4, 1 plus 2 which is 3. So the values will be 3 comma 4 which I got here, right? 3 and 4. So this is what we are doing. Let me name it as minimum x and let me name it as maximum x. So what I am doing in the algorithm, I'll write the algorithm here. So the algorithm goes like taking c is equal to 0, L is equal to 0, H is equal to 0, and for every number in differences c plus is equal to num. Okay, now L is equal to minimum of L comma c and H is equal to maximum of H comma c, and then I'll take minimum x is equal to minimum x which I wrote here is lower minus L. Okay, lower minus L, and max x is equal to, I'll write it again here, upper minus H. Okay, upper minus H. Now the how many like numbers I can get, it will be written maximum of I don't know why this maximum is not working here. So 0 is greater than uh, max x, right? Max x minus minimum x plus 1. So if it is greater 0, or I'll return max x minus minimum x plus 1. Max x minus minimum x plus 1. Okay, so this is how you solve this problem. It's just a 4 lines code. So you can get the code, both the codes of approach 1 and the optimized approach, in the description. Go and check it. And if you like this video, do share it to friends and do subscribe to my channel. Thank you.